Hello everyone, welcome to a new video. Harsh Verma this side, and today our topic for the day is OSPF by the same book Network Warrior. For who those are new that I've just watched this video, actually we are going through the book Network Warrior. Let me show you the book first. So this book is particularly about the practical lessons that was not well understood or explained in the CCNA preparation. So this book outlines the topics in CCNA, does not explain in detail, but only takes the talks about the things that are practical enough that will be used in real life scenario. So I've been learning this book for the past few days, and there's been videos. What I do is to make some notes and share the notes with you in a video format with you all. Okay. So without any further delay, let's jump to our topic for the day is OSPF. But the first disclaimer is that OSPF is a topic that is only well understood when it is done practically. So I've been learning theoretically OSPF multiple times through the deep dive videos of Kevin Wallace, through Jeremy IT Lab, through this book, through all other multiple sources. I've watched multiple videos regarding the OSPF, and every time I watch about OSPF, I learn something new, and for sure I tend to forget few things because OSPF is just a very large topic. So don't take every word of me, take my word as a grain of salt, because I will be learning by reading this in front of you. Because when I actually first learned about the OSPF in the Network Warrior book, I feel like I have mistaken, or I have been forgotten a few things. So without any further delay, let's zoom into the terminal session so we can begin. Where the OSPF starts? Yes, so it starts from here by the full form. OSPF stands for Open Shortest Path First. And what does it do? It is a link state internal gateway routing protocol. So it works within an autonomous system, route sharing, distribution, not route multiplication. It's distribution. So the OSPF calculates bandwidth by dividing the link bandwidth into in bits by 1 million, and 1 million contains 10 to power 7 into 10, matlab a total of 10 to power 8 zeros. One with 80, sorry, one with 80. Okay. Now the OSPF defines router. For example, if there's a group of routers that is running the OSPF process, then the OSPF router assigns itself a position. It may be an internal router, a ABR, which stands for area boundary router, a ASBR, which stands for autonomous system border router. Then it's a backbone router, it may be a designated router, it may be a backup designated router. So these router types sometimes overlap. For example, a single router can become an internal router and a designated router, or an internal router or a backup designated router. It may be an area border router, etc. So these designations does not contrast specifically. It may be a gray zone. There may be two routers with the same with multiple router types, or there may be single router with multiple router types. So it happens like that. So let's start by understanding what an internal router is. So internal router is a router residing within the single OSPF autonomous system. So if a router that is under a single autonomous system, which because OSPF is an within autonomous system process, so kind of every router is an internal router. Okay. Then we have area border router. If you are totally new to OSPF, please watch a deep dive video. I also recommend watching a deep dive video with a much better practitioner, trainer, or mentor than me. Uh, but area boundary router, because OSPF defines the area in which it tends to share out, the frequency of updates, the type of update will be defined by the area. So if it's a area 0, then it will be called an internal router to that area. But if a router that is sharing between two areas, means one of the interface is connected between one area while the other is connected to another area, in that scenario, that router will be considered area border router. Next is autonomous system border router. autonomous system even if the router connecting multiple OSPF autonomous system, not to be confused with the autonomous system which we study in BGP, that is defined by some autonomous system number or other routing protocol. For example, OSPF starts redistributing route between an EIGRP protocol or RIP protocol, then that router would be considered as autonomous system border router because it is on the border of the edge of the autonomous system, OSPF process. Next is a backbone router. The router that is present in the area 0 is called backbone router, and the area 0 is simultaneously called the backbone area. Okay, finally, the designated router. The router designated or dedicated to perform all the OSPF processing because calculation of a shortest route is a tedious process. So if we engage every router in calculation, it may slow down the network, it may lead to higher CPU uses. So we dedicate this task to a particular router in the area, and this all be defined by some form of election which we'll talk about in just a few moments. So the router performing all those calculations is called designated router, and they once calculated this shortest area, it will be updated to all other routers present in that area. And finally, the backup designated router. So it is the most eligible router which will become designated if the main designated router fails. Okay. OSPF, what it does to do, OSPF router sends LSA. LSA stands for link state advertisement. Instead of updated, other router build their internal database using this LSA. So calculation is performed by that single router. After performing the shortest path calculation, it shares its update using LSA, link state advertisement, and there may be different types of LSA because OSPF operates on area basis. So depending on the type of area, the LSA varies. So the first LSA, which is also known as type 1 LSA, is router LSA. We are covering three things about each LSA. The origin of type 1 LSA is every OSPF router, one per area. Okay. So the purpose of it is to describe the router links to network and neighbors inside the area, which is being shared by the LSA, including the link type, the metric, etc. And this is scope is area local. So the area or the type 1 LSA is not shared outside of that area. Okay. Next is type 2 LSA, which is also known as network LSA. The designated router, it originates from the designated router for a multi-access network. What is a multi-access network, you may say? One second, let me help you understand by explaining its purpose. So, type 2 LSA describes the router attached to a multi-access network, lists attached router and network mask, and its scope is also area local and it is not flooded outside the area. So it does not actually explains the multi-access. A normal human being, what I will do, I will copy this, go to our web browser, open a new tab with an LLM model. Let's use Claude here. Multi-access network in OSPF. And let's ask it. So a multi-access network in OSPF is a network segment where multiple routers can connect to the same shared medium and communicate directly with each other. The most common example is local area network using Ethernet, where many routers can be physically or logically connected to the same broadcast domain. Okay, that's it. That's enough for this. Okay. So what is the contrasting difference between type 1 and type 2 LSA? Actually, the type 2 LSA is originated from the designated router, but the type 1 LSA is designated by every OSPF router once per area. So, if in a multi-area setup in which we have area 0, the backbone area, the area 1, the area 2, the area 3, what will happen that every router once in per area will originate the type 1 LSA, while type 2 LSA is only originated by the designated router. Okay. Now time for type 3 LSA, which stands for summary LSA for inter-area network. Inter area means between two or more areas. Okay. So it is originated by area border router. We know that area border router is a router that connects two areas. Okay. So the purpose is to advertise the network from one area to another, which is quite very explaining. And scope, it is flooded into other areas but not into the originating area. So if it originating from area 0, then it will be flood into area 1, area 2, etc., but not back to the area 0, because it will create a loop. Okay, the next type for LSA is also called summary LSA, but it is for ASBR, Autonomous System Border Router. Boundary. One second. Autonomous System Border Router. So it's a border router. Okay. What is say that it is originated from the ABR, the same ABR, area boundary router, on behalf of Autonomous System Border Router. Okay. But what is purpose? It advertises the reachability to an autonomous system border router, provides path to the ASBR, so routers know where to send traffic for external route. So basically it advertises the external routes. In plain language, we can say. And next thing is, one second, where I was. Area local propagation as needed means it does not usually get advertised outside the area, but if the requirement is to announce the externally, it may be sent externally. About type 4 LSA. Now, talking about the type 5, which stands for autonomous system external LSA. It is originated from the ASVR, Autonomous System Border Router, and present in other routers after flooding. The purpose is to advertise the route external to the OSPF autonomous system, or we can say the imported external routes from the other protocols. And the scope is to flood all the standard areas. Type of LSS are not flood into stub or totally stub. Okay, we have to start is understand the area types. I was slight missing that we have not covered stub area or totally stub area yet, and it's a very confusing topic. I myself has not understood fully as well, so I will also be trying to understand. Just like making this video, I'm trying to explain everything. So if needed, I will take the help of AI. Actually, I must have created few notes in the backend, so I will also show you that. Okay, so the type 5 autonomous system external LSA has a purpose to advertise routes external to the OSPF autonomous system, and it has scope to flood all the standard area. Type 5 LSS are not flooded into a stub or totally stub area. Okay, so it does flood in all areas except a stub or totally stub area. And finally, there is no type 6 LSA. The next is type 7 LSA, which stands for NSSA LSA, which stands for not so stubby, not so stubby area. Okay. So the origin of type 7 LSA is ASBR inside an NSSA. So autonomous system boundary router inside a not so stubby area. And what's its purpose? Its purpose is to advertise an external route into an SSA. Type 7 is flooded only within SA. Converted type 5 is a flooded outside. So let me first clear what an stubby area is. So stubby area, in easier word you can say, that is a secluded or excluded area which does not have any routes to other areas or destination. It only has one link to share the information into OSPF or from OSPF. So the area which is segregated into a different domain and only one access to OSPF, that area is called stubby area. We also have its variant which is not so stubby area, totally stub area, etc. So let's see, we will in the next one. Yes. So OSPF mainly has two forms of area, not four, only two. So first is backbone area or other is non-backbone area. The backbone area is also known as area 0, and all area must connect to backbone in order to communicate with each other. So backbone is called backbone because it acts as a central hub for all other areas for interconnection. Second is non-backbone area, which is further divided into five types. The first is normal, stub, totally stub, not so stubby, and not so stubby, totally stub area. So it's a hella confusing. So let's start with the normal one. The area 0, which is backbone area, except that every other area is known as normal area. And if it does not have any special configuration. Next is stub area, the area that does not allow the type 5 LSA. It is called a stub area. So if I like the Claude to explain me the simplest explanation regarding the stub area, explain to a layman stub area in OSPF. A stub area. Imagine your company has a main office that has several branches connected to a network. A stub area is like a branch office that only needs to know the way out of main office and does not care about all the details of other branch office. Okay, so it's quite very just like information that I've just shared. That stub area is totally disconnected with a single link with for the information transformation or transposition or sharing or synchronization, etc. Okay, so the totally stub area is the area that does not allow the type 3, type 4, type 5 LSA except the default summary route and local to area route. Finally, not so stubby area is an area that does not allow type 5 LSA except the converted type 7 into type 5. And finally, not so stubby, totally stubby area, that area that does not allow type 3, type 4, type 5 LSA except the default summary route and convert it into type 7. So my recommendation is to at least write this thing at least 4 to 5 times in order to get it remembered into memory, and we will see if there's a easier way to understand this. Okay. OSPF interface priority ranges between 0 to 255, but what an interface priority is and what it does. One second. The default priority of OSPF router is 1, while the priority of 0 means it is not eligible to become a designated router. So OSPF priority is kind of election metric. The lower the metric, I think the lower the metric, the worst is it in case of OSPF, because in STP, spanning tree protocol, the lower the metric, higher it is to become the root. But in OSPF, it is quite opposite. The higher the metric is, the higher the priority is, the higher the chance of a router becoming the designated router. So the router with second best metric will automatically become the backup designated router. One second, my alarm's ring. Please allow me 1 second. Can I pause this?